In this interaction, we are given the information that Farmer Francisco needs to design a new rectangular corral for his cattle. He has 200 meters of fencing to do this. How should he build the corral to maximize the area for his cows? We first need to start with these three boxes. The first box says, what is the total fence length? Well, because we have 200 meters of fencing to do our fence, we'll substitute in 200. And the number of lengths? Well, we could make this side and this side the lengths, so we have two of them. And this side and this side could be the widths, so we have two of those. Next, we need to determine which two equations will help Farmer Francisco solve the problem to get a maximum area for his 200 meters of fencing. We first need to start with the perimeter function. We have 2 lengths and 2 widths is equal to our perimeter, so that'll be our equation 1. In addition, we need to come up with a function for area. The area of this figure is equal to length times width, so we'll substitute that right here. Next, we need to deal with equation 1 first. Perimeter is equal to 2L plus 2W, and substitute in the corresponding length. So we have 2 widths, we have 2 lengths. We know that the perimeter is equal to 200, so we can substitute 200 in for P. Now from here, we need to isolate for L. So we'll take our 2L, and we'll subtract 2W from both sides of the equation. And of course we have our 200, so we have the 200 minus the 2L, like so. Now in order to isolate for L, we'll divide both sides by 2. So we'll take 200 minus 2W, all divided by 2, which simplifies to give us L is equal to 100 minus W. Now that we have that information, we can substitute that into our equation 2. We know that the area is equal to length times width, and of course the length is equal to 100 minus W that we just figured over here. So we'll substitute that in first, and we'll substitute W in here. Next, if we distribute the W across the 100 and the W across the 1W, we have 100 times W is 100W, and W times W will give us W squared. Next, we'll write in descending order of powers, such that we have negative W squared first, and then plus 100W. When we take the function A is equal to negative W squared plus 100W, and we complete the square, we're left with A is equal to negative 1 onto W minus 50 all squared plus 2500. Notice that this is in vertex form. We've completed our square. From here we can determine that our maximum area is 2500 meters. In addition, because we know that the width is equal to 50, the other dimension we can substitute into our length function such that we have 100 minus 1 times 50, or 100 minus 50, which tells us our other dimension is also 50.